Hello students, welcome to the class. Our next topic is that is thermal properties of matter. Already synopsis we have completed. Let us continue with the multiple choice questions. The first question is the freezing point on a thermometer is marked as 20 degrees Celsius and the boiling point at the as 150 degree Celsius. A temperature of 60 degree on this thermometer will read as, so what they have given, the freezing point is marked as 20 degree and the boiling point at 150 degree. A temperature of 60 degrees Celsius on this thermometer, it will read as. So here we know the formula, that is the relation between temperature scale. It is given by x minus x is the temperature, okay, lower fixed point divided by upper fixed point minus lower fixed point is equal to what? It is constant. So this x I'll write as it is minus lower fixed point. How much they are saying? The freezing point, it is marked as 20. So x minus 20 divided by upper fixed point is 150 minus lower fixed point is, it is 20, which is equal to c divided by 100. Right? Now we can simplify this for x is equal to, therefore we will get it as x is equal to c into 150 minus 20 is 130 divided by x. We need to calculate, keep it as it is. Okay. Here it is divided by 100. Minus 20 is there. If it comes to the other side, it becomes plus 20. It becomes plus 20. Therefore, if I simplify this one, I'll get it as x is equal to a temperature of 60 degrees Celsius they have given. In degrees Celsius, it is 60 into, this is 130 divided by 100 plus 20. This is equal to 98 degrees. So that is 60 into 130 divided by 100 plus 20 will give us 98 degree. Therefore, the option is B. Option B is the right option here. 98 degree. Okay. Next question. Recently, the phenomenon of superconductivity has been observed at 95 Kelvin. The temperature is nearly equal to. So, we need to calculate the temperature at 95 degree, 95 Kelvin. We can use the same formula, that is the relation between two temperature scale. See here. Again, we have the formula, that is x minus lower fixed point divided by upper fixed point minus lower fixed point is equal to constant. So write this. This is F minus 32, that is Fahrenheit scale, divided by 212 minus, because here the options are given, actually this is in terms of degree Fahrenheit. It is given in terms of degree Fahrenheit, right? So this is given in terms of degree Fahrenheit. This is also degree Fahrenheit. This is, all the four options are given in terms of degree Fahrenheit, and in the question the temperature is given in terms of Kelvin. So I am taking the relation between degree Fahrenheit and the Kelvin. So it is F minus 32 divided by 212 minus 32, which is equal to k minus 273 divided by 373 minus 273. So this can be written as f minus 32 divided by 212 minus 32 is how much? It is 180. It is 180, which is equal to k minus 273 divided by 100. K minus 273 divided by 100, which can be written as f minus 32 divided by 9 is equal to k minus 273 divided by 5. Means here this is 180 and 100. If I simplify this, I can write it as, here it is, yeah, my f minus 32 by 9 is equal to k minus 273 divided by 5. Okay. Therefore, simplify this equation for f is equal to, so how we can write here, see, f is equal to, I can write it as 9 by 5 into bracket, k value is 95 minus 273. So simplify this one. Okay, whatever answer you are getting here, that will be minus, here. Then minus 32 is there. If it comes to the other side, it becomes plus 32. So simplify this all things, you will get, do it yourself. So after simplification, you need to get the answer as 288 degree Fahrenheit. 288 degree Fahrenheit. That is option A is the right option here. Option A is the right option. Next one. So here the graph is drawn. Okay, the graph AB shown in the figure is a plot of temperature of a body in degree Celsius and degree Fahrenheit. Then, so here what they have given, the graph AB shown in the figure, it is a plot of temperature of a body in degree Celsius and degree Fahrenheit. Then option A is, it is slope of line AB is 9 by 5, slope of line AB is 5 by 9, slope of line AB is 3 by 9, or slope of line AB is 9 by 3. So how to do this one? If you see the graph, it is the relation between Celsius and Fahrenheit scale. So we need to take the relation between Celsius and Fahrenheit scale here. From that we need to simplify. The relation between Celsius and Fahrenheit scale is given by, it is C divided by 5 is equal to F minus 32 divided by 9, which is equal to, C is equal to 5 by 9 minus it is 160 divided by 9. So what I did, I multiplied this 5 to the entire bracket. So 5 into 32 is 160 after simplification. So now what we can do, we can compare this equation with our equation of a straight line, that is given by y is equal to mx plus c, where m is the slope here, Therefore, if we compare the equation, this equation with our equation of a straight line, in place of m, we have 5 divided by 9. We have 5 divided by 9. That is option B is the right option. That is slope of line AB is what? It is 5 divided by 9. Option B is the right option here. Okay. So this is how we can calculate. Not only this graph, if any other graph is given with the relation between the two scales, we can calculate. Then we can compare it with equation of a straight line, which will tell the slope of a given straight line. Next question. The design of a physical instrument requires that there be a constant difference in length of 10 centimeter between an iron rod and a copper cylinder laid side by at all temperatures if coefficient of iron is given, coefficient of linear expansion for iron is given 11 into 10 raised to minus 6 degree Celsius per degree Celsius, and for copper it is 17 into 10 raised to minus 6 per degree Celsius. Then lengths are. So we have a relation that is given by delta L is equal to L into alpha delta T. Here delta L of iron is equal to L of copper. Okay. So for iron, as we know this equation, that is delta L is equal to L alpha delta T. So delta L is equal to L alpha delta T. Here I can write that is L of iron into alpha of iron into delta T, which is equal to L of copper into alpha of copper into delta T. Now, if I take the ratio of L of, that is length of iron divided by length of copper, is equal to alpha copper divided by alpha of iron. Okay, so here the alpha values are given. So for copper it is 17 divided by, for iron it is 11. For iron it is 11. I can name this equation as equation 1 or equation 2 we can name. I will name it as equation 1. So from equation, we also know that is the lengths are given, that is the instrument, the length of 10 centimeter between an iron and a copper rod they have given. The length difference is how much? It is 10 centimeter. So therefore, how we can write it? When we know it is 17 divided by 11, we can simplify this equation. And we will get it as L of copper is equal to 18.3 centimeter, and for iron it is 28.3 centimeter. Okay, so after simplification, we will get the length as 28.3 and 18.3. That is option A is the right option. Option A is the right option. Okay. So by using delta L is equal to L alpha delta T, we can calculate the length of the given two rod, which is used to design the given instrument. Next. A iron rod of length 50 centimeter is joined at an end to an aluminium rod of length 100 centimeter. All measurements refer to 20 degrees Celsius. All the measurements refer to a 20 degree Celsius. The coefficient of linear expansion of iron and aluminium are. The coefficient of expansion of iron and aluminium are given by. It is 12 into 10 raised to minus 6 per degree Celsius and 24 into 10 raised to minus 6 per degree Celsius respectively. The average coefficient of composite system is. It is given by at 20 degrees Celsius, length of composite system, it is L is equal to 50 plus 100, that is equal to 150 centimeter. That is equal to 150 centimeter. See, length of iron rod at 20 degrees Celsius, it is 50 centimeter. And length of aluminium rod is 100 centimeter, which is given. So length of iron rod at 100 degrees Celsius is given by, see here, we have a rod, iron rod 50 centimeter, which is joined to the aluminium rod of length 100 centimeter. Therefore, the total length becomes how much? The 150 centimeter. Here, during this process, the temperature is 20 degrees Celsius. The coefficient of linear expansion of iron and aluminium is given. The average component system, we need to calculate here. Therefore, for iron rod, the length is given by, at 100 degrees Celsius, how we can do it? That is given by, so length of iron rod at 100 degree Celsius is equal to 50 100 minus 20. So this is equal to, it is 50.048 centimeter, 50.048 centimeter. Similarly, for aluminium rod, we can write it as, it becomes 100 into bracket 1 plus 24 into 10 raised to minus 6, then 100 minus 20, which is equal to 100.192 centimeter. Okay, at 100 degrees Celsius, the length of composite system is given by, L dash is equal to 50.048 plus 100.192. This is equal to 150.24 centimeter. Then change in length of the composite system is given by, delta L is equal to L dash minus L. So L dash value is how much? It is 150.2 minus L value is how much? It is 150. Therefore, we will get it as 0.24. We will get it as 0.24 is the average, is what it is, change in length. What we need to calculate? We need to calculate the average coefficient of composite system. That is alpha value we need to calculate for this change in length. I hope this step is clear to everyone. At 20 degrees Celsius, we have calculated the total length. Then next we need to calculate the total length when both the rods are heated to 100 degrees Celsius. So what we did here, we have calculated the length. Now the change in length is 0.24. So for this change in length, we need to calculate the value of alpha. So this I'll erase, then I'll go for alpha calculation formula. See here, the average coefficient of expansion at 100 degrees Celsius. How to do this? That is, alpha is equal to, our formula is delta L divided by L into delta T. So change in length is 0.24 divided by original length is 150 into change in temperature. It is 100 minus 20. It is 100 minus 20, which is equal to, so here it is 100 minus 20 is nothing but what? It is 80. 150 into 80, that is 0.24 divided by 80. You will get it as 20 into 10 raised to minus 6 per degree Celsius. 20 into 10 raised to minus 6 per degree Celsius is the value of coefficient of linear expansion when both the rods are combined and heated at 100 degrees Celsius. Therefore, option C is the right option here. Okay. Next question. A glass flask of volume 1 liter at 0 degrees Celsius is filled. Level of mercury at this temperature the flask and mercury are now heated to 100 degrees Celsius. How much mercury the flask and mercury are now heated to 100 degrees Celsius. How much mercury will spill out if the coefficient of volume expansion of mercury is 1.82 into 10 raised to minus 4 degrees Celsius and linear expansion of glass is given as 0.1 into 10 raised to minus 4 per degree Celsius respectively. So here a glass flask of volume at 0 degrees Celsius, it is filled. Okay, the level of mercury at this temperature. Now, when it is heated to 100 degrees Celsius, some mercury will spill out. The coefficient of linear expansion is given and volume expansion is given. Here, we need to calculate that whatever the change in volume takes place. Right? So here it is given by change in volume of liquid relative to container. It is given by this relative to container. It is given by delta V is equal to V into bracket, that is gamma into L minus gamma into S, gamma S into delta theta. So V value is 1000 cc, right? Then gamma L is equal to, it is 1.82 into 10 raised to minus 4 per degree Celsius. Then we know that gamma G is equal to 3 times of alpha G, right? Means here what it is, gamma and alpha relation, that is it is in the ratio of 1:3. Therefore it can be written as gamma is equal to 3 alpha, which is equal to 0.3 into 10 raised to minus 4 per degree Celsius, per degree Celsius. Okay. Next. So now we know that the change in volume can be calculated as change in volume. V is equal to, it is V into bracket gamma L minus gamma S into delta theta. So V is given as 1000. Substitute all the values now. So V is given as 1000 into bracket gamma L value is, it is given in the question, it is 1.82 into 10 raised to minus 4 minus gamma S value. So gamma S value is 0.3. Just now we have calculated, it is 0.3 into 10 raised to minus 4 into temperature is 100. Temperature is 100. This is equal to. So if we simplify this, we will get it as 15.2 cc. We will get it as 15.2 cc. That is option B is the right option here. Option B is the right option. Okay. Next question. Liquid is filled in a flask up to a certain point. When the flask is heated, the level of liquid, what happens? See, immediately starts increasing, initially falls and then rises abruptly, then falls abruptly. See here, so rises, suddenly rise, suddenly fall, it will not take place. So B, C and D, it is not true. A and B, here immediately it starts increasing. No, that is also not true. Unless and until all the molecules will acquire the same temperature, the temperature will not increase or the level will not increase. Okay, so option B is the right option. That is initially falls and then rises. So how we can explain this? Since the liquid and the flask undergo volume expansion and the flask expands first, therefore the level of liquid initially falls and then next it rises. Option B is the right option here. Option B is the right option. Next question. The absolute coefficient of expansion of a liquid is 7 times that the volume coefficient of expansion of the vessel. Then the ratio of absolute and apparent expansion of the liquid is. So here it is given the absolute coefficient of expansion of a liquid is 7 times that the volume coefficient of expansion of the vessel. Then the ratio of absolute and apparent expansion of the liquid is given by. So here it is written that is gamma L is equal to 7 times of gamma. Yes. Okay. Apparent coefficient of volume expansion is given by. So this gamma apparent is equal to gamma L minus gamma S, which is equal to gamma L. We have just now written it is 7 alpha gamma S minus gamma S. That is nothing but 6 into gamma S. Okay. Then now the ratio of absolute and the apparent expansion they have asked. So it is given by gamma L divided by gamma apparent is equal to. So this is gamma 7s divided by 6 7s. Sorry, 6 gamma s. So gamma s will get cancelled. Therefore, you will get it as what? 7 divided by 6. We will get it as 7 divided by 6. That is option B is the right option. Next question. In cold countries, water pipes sometimes burst because of. So option A, pipe contracts, water expands on freezing, water freezes, pressure increases. Option 4, when water freezes, it takes heat from pipes. Okay. So here what happens in according to anomalous expansion. So this concept is based on anomalous expansion. So during anomalous expansion, what happens? That is between 0 to 4 degrees Celsius, instead of expanding, it will contract, right? Then next, after that, it starts expanding. So therefore, water expands on freezing. That is option B is the right option here. Because of that, in cold countries, water pipes sometimes burst. Right? The next question. A clock with a metal pendulum beating seconds keeps correct time at 0 degrees Celsius. It keeps correct time at 0 degree Celsius. If it loses 12.5 seconds a day at 25 degrees Celsius, so if it loses 12.5 seconds a day at 25 degrees Celsius, the coefficient of linear expansion of metal pendulum is, see here, a metal pendulum, it is beating at 0 degrees Celsius and it loses 12.5 seconds a day at 25 degrees Celsius. So when the temperature is changed to 25 degrees Celsius, it loses 12.5 seconds. The coefficient of linear expansion of metal pendulum is, we need to calculate the alpha value here. See, it is given by so loss of time due to heating a pendulum is given by that delta T is equal to 1 divided by 2 alpha delta theta into T. So it is delta T, it is 12.5 is equal to 1 by 2 into alpha into delta theta value is 25 minus 0 into T. It is given as 12.5 seconds. So convert it. We will get it as into 86400. Okay, simplify this equation for alpha is equal to, which implies alpha is equal to, we will get it as, it becomes 12.5 into 2 divided by 25 into 86400. So therefore we will get it as 1 divided by 86400, that is equal to alpha, that is equal to alpha, that is option A is the right option here. The alpha value is found to be 1 divided by 86400 per degree Celsius. So loss of time is given by delta T is equal to 1 by 2 delta theta into T into alpha. Next, a steel bar of area of cross section 0.01 meters square is fixed between two concrete blocks and the temperature of the steel rod is increased by 20 degrees Celsius. What will be the force on the concrete blocks if the steel rod is not allowed to expand? If the steel rod is not allowed to expand. So we need to calculate the force here. So that force is equal to gamma into alpha into A into T is the formula to calculate force. That is thermal stress formula here. It is given by F is equal to 2 into 10 raised to 11 into 0.01 into 12 into 10 raised to minus 6 into 20. So if I simplify this, I'll get it as 4.8 into 10 to the power of 5 Newton. 4.8 into 10 to the power of 5 Newton. That is option A is the right option here. Okay. Next question. A cylindrical metal rod of length L is shaped into a ring. You can see the figure here with a small gap as shown. You can see a cylindrical metal rod of length L is shaped into a ring with a small gap as shown in the figure on heating the system. So on heating the system, what happens? See here, X decreases, R. So R here it is given, okay? That is radius. R is here, it is mentioned. X decreases, R and D increases. X and R increases, D decreases. X, R and D all increases. data is insufficient to arrive at the conclusion. See, when a metal rod is bent in the form of ring, okay, so on heating, what happens here? On heating the system, X, R and D, that is diameter, length, it all increases since the expansion of isotropic solid is similar to true photographic enlargement. Okay, so everything increases here, all increases. Option C is the right option. Then the next question is, so here also you can see the figure. Two holes of unequal diameters D1 and D2 are cut in a metal sheet. They are cut in a metal sheet. So you have a metal sheet. The metal sheet is cut into a unequal diameter. It is cut into a unequal diameter. If the sheet is heated, so when the sheet is heated, what happens? If the sheet is heated, then both the diameter options are the both will decrease, both the diameter will increase, d1 will increase, d2 will decrease, d1 will decrease and d2 will increase. See what is the correct option here? When the sheet is heated, then both diameter will increase because of what? Thermal expansion property. Okay, so it will increase here. Then the next question is, if spheres, two spheres are made up of same substances have diameters in the ratio of 1:2. Their thermal capacities are in the ratio of, the thermal capacities are in the ratio of. So let us solve this. We have thermal capacity is equal to, that is, the formula is thermal capacity is equal to mass into specific heat. Thermal capacity is equal to mass into specific heat. So when they are of the same mass, we can write it as m1 divided by m2 is equal to v1 rho divided by v2 into rho. This is equal to, so this is equal to, volume is written as 4 by 3 pi r1 cube divided by 4 by 3 pi r2 cube. So this is equal to, this is equal to, it can be written as r1 divided by r2 to the power of 3 is equal to. So what is the ratio they have given? It is given as 1 by 2 whole cube. So 1 by 2 whole cube is nothing but what it is? 1:8. It is 1:8. That is option B is the right option here. Okay. When 300 joule of heat is added to 25 gram of sample of a material, its temperature rises from 25 degrees Celsius to 45 degrees Celsius. The thermal capacity of the sample and specific heat of the material are respectively given by. See here, when 300 joule of heat is added to 25 gram of sample. So heat Q value is given, mass is given, the temperature changes, that is initially it is 25, changes to 45. Thermal capacity of the sample and specific heat of the material are respectively. So here thermal capacity is equal to M into C. Thermal capacity is equal to MC. That is given by MC is equal to Q divided by delta T. Okay, Q value is given as 300 divided by delta T is how much? It is 45 minus 25. 45 minus 25, that is 300 divided by 20. So 0 0 will get cancelled. 2 15. That is 2 and the 215s are 15 joules per degree Celsius. 15 joules per degree Celsius. Okay, so this is what? This is thermal capacity. Next, we need to calculate the specific heat also. So how we can calculate specific heat? Specific heat is given by specific heat is equal to thermal capacity divided by mass. Thermal capacity divided by mass. So thermal capacity is how much? It is 15 divided by mass is how much? It is 25 into 10 raised to minus 3. 25 into 10 raised to minus 3. Thermal capacity, just now we have calculated. Mass is given as 25 gram. Convert it in terms of kg, it becomes 25 into 10 raised to minus 3. This is equal to, it becomes 600. 600 joules per kg degree Celsius. That is option A is the right option here. Right? 15 is thermal capacity, then specific heat is 600. Option A is the right option. According to the question, we will get it as option A is the right option. Okay. If it is given as specific heat capacity, then this one, then it will be option B. But here it is given as thermal capacity, then specific heat. Therefore, option A is the right option. Then next question. Work done in converting 1 gram of ice at minus 10 degrees Celsius into steam at 100 degrees Celsius. We need to calculate the work done in converting ice into steam. They have given the temperature. So, we have work done in, here I'll write, work done in converting 1 gram of ice at minus 10 degrees Celsius to steam at 100 degree Celsius. That is equal to, it is given by W of work done for ice to convert from minus 10 to 0 degrees Celsius. First, it will convert from minus 10 to 0. Then work done here from 0 to 0. That is from solid to liquid. Next, plus water at 0 to 100. 0 to 100. Next, one more state, the work done water from 100 to liquid to steam, right? These all process takes place here. Okay, these all process takes place. That is what, when initially ice is at minus 10 degrees Celsius, it will get converted to 0 degrees Celsius ice. Then that ice will get converted in the form of liquid, that is to the same temperature. Then work done is 0 to 100 degrees Celsius. Then next 100 degrees Celsius of liquid to 100 degrees Celsius of steam. We need to calculate work done in 4 steps. So either we can simplify it separately, or here only we can calculate. We know that work done is equal to mc into delta T. mc into delta T. So let us write. Here it is m into C of ice into delta T. First bracket, plus here change of state, therefore it is m into L of ice, plus temperature change, that is m C of water into delta T, plus m into L of water, m into L of water. This is equal to So M mass is 1 gram it is given. So 1 gram into specific heat capacity of ice. It is 0.5 calorie per gram per Kelvin. So it is written as 0.5 into 10, change in temperature is 10, plus here we have it is 1 into 80. It is 1 into 80 plus 1 into 1 into 100 plus it is 1 into, that is latent heat of water, it is 540. Okay. So after substituting all the values, we will get it as 725 calories, because in CGS system we have calculated, we will get it as 725 calories. Converted in terms of joule, what is the conversion factor? So 725 into 4.2, that is equal to, it is 3045 joules. 3045 joules. That is option A is the right option here. Option A is the right option. So as it is converting from solid to steam, the 4 step of work done we need to use. If it is solid to gases, then 3 step will come. Like that, the work done calculation will change. We need to observe the question properly and we need to see from which state to which state it is getting converted. Okay. Next question. 2 kg of ice at minus 20 degrees Celsius is mixed with 5 kg of water at 20 degrees Celsius. So you have 2 kg of ice and 5 kg of water. The temperature is minus 20 degrees Celsius and here it is 20 degrees Celsius. In an insulating vessel which is having a negligible heat capacity, calculate the final mass of water which is remaining in the container. It is given that the specific heat of water and ice are 1 kilocalorie per kg per degree Celsius and 0.5 kilocalorie per kg per degree Celsius, while the latent heat of fusion of ice is given as 80 kilocalorie per kg. Okay, so see here. Initially, ice will absorb heat to raise its temperature from minus 20 degrees Celsius to 0 degrees Celsius. Then its melting takes place. So when the water is getting converted from minus 20 to 0 degrees Celsius, the melting process takes place here. We need to calculate the change in mass. Okay, how we can do this here. That is heat for increasing the temperature of ice plus heat for melting of ice. First one is what? Heat to increase the temperature of ice. Next one plus heat to melt the ice is equal to heat loss by water. Heat loss by water. So write the value here, that is given by mc into 20 plus m into L, or we can take it as m dash, is equal to m into W, C into W into 20. So substitute the value, that is 2 into 0.5 into 20 plus m dash into 80 is equal to 5 into 1 into 20. Therefore, if you simplify this, m dash is what? It is the mass of ice that melts. mw is initial mass of water, m is initial mass of ice. So here if you simplify this, you will get it as 1 kg. You will get it as 1 kg. So now final mass of water is given by. So final mass is equal to initial mass plus mass of ice that melts. it is equal to 5 plus 1, that is nothing but 6 kg. That is nothing but 6 kg here. That is option B is the right option. Option B is the right option. Okay. One more question. So next question is, if mass energy equivalent is taken into account when water is cooled to ice from form ice, then mass of water should, see here what it is given, mass energy equivalent, that is Einstein's equivalent relation. By considering that when water is cooled to form ice, the mass of water should, so what happens to the mass of water? See here, when water is cooled at 0 degree Celsius, when water is cooled at 0 degree Celsius to form ice, then 80 calorie per gram energy is released, right? So when it is cooled at 0 degree Celsius, 80 calorie per gram energy is released because potential energy of the molecules decreases. Mass will remain constant. That is nothing but what? Freezing of water. That is nothing but freezing of water here. Okay. So which means that it remains unchanged. The mass will not change. The mass remains constant. Right. Option B is the right option here. Next. Compared to a burn due to water at 100 degrees Celsius, a burn due to steam at 100 degrees Celsius is, which is more harmful. See what they are asking. When burn occurs, when the water is 100 degrees Celsius, that is more effective, or when it is steam. See, options are given as more dangerous, less dangerous, equally dangerous, none of these. That is, see, the steam at 100 degrees Celsius contains extra calories of 540 calorie per gram as compared to the water. So it's more dangerous when it burns with the steam than with the water. Therefore, option A is the right option here. Means steam will give more dangerous. Okay. Then 50 gram of copper is heated to increase its temperature by 10 degrees Celsius. If the quantity of heat is given to 10 gram of water, then the rise in its temperature is. So we need to calculate the rise in temperature. We know that the formula. So we have mc into delta Tc is equal to, that is in water, mw into delta Tw. Simplify this for delta Tw is equal to mc into delta Tc divided by mw into Cw. So that is equal to, so mc value is how much? It is given as mass of copper is given as 50 into 10 raised to minus 3 into Cc. It is 420 specific heat capacity into change in temperature is 10 divided by. So mass of water, it is 10 into 10 raised to minus 3 into specific heat capacity is how much? It is, we know it is 4200 is equal to Tw. Therefore, this Tw is equal to 5 degree Celsius. It is 5 degree Celsius. That is option A is the right option here. Option A is the correct option. Okay. In the next class, we will see few more numericals based on thermal properties of matter. Okay, students. So go through the formulas. Formulas are very important here. right? In the next class we will continue.